Swayam Prabha. Digital India. Educated India.
Welcome to this class on adipose tissue metabolism. I am Sambit Das from Department of Biochemistry, Malakka Manipal Medical College, Manipal Academy of Higher Education, Mahe, Manipal. In this quick class, we shall see various aspects of adipose tissue and the metabolism that happens in it. Let us begin by asking this question: where is adipose tissue found? Adipose tissue is largely found in the subcutaneous region under the skin, and that comprises of 80% of body fat. The adipose tissue around the digestive organs like stomach, intestines and including kidneys comprise the intra-abdominal region which comprises of 20% of body fat. The majority of adipose tissue is found in abdominal and scapular region in upper body and gluteal and femoral region in the lower body. So, what are the components of adipose tissue? The adipose tissue comprises of the lipid storing adipose cells and a vascular compartment which includes pre-adipocytes and macrophages. To give you an overall idea, in a 70 kg man, the white adipose tissue weighs around 14 kgs, which is almost half the muscle mass. The adipose tissue has a loose network of elastin and collagen fibers. Let us see the few functions of adipose tissue. They serve mainly as major food source for the body. They provide mechanical support. They do have an endocrine function where they regulate metabolism. They provide cushioning effect to the internal organs, and they also function as insulator for our body. So, what are the types of adipose tissue that are found? There are broadly two types of adipose tissue in mammals: the white adipose tissue and the brown adipose tissue. So, white adipose tissue is the most common and serves the functions mentioned above. The brown adipose tissue, which appears brown because of the large number of mitochondria found in them, are mainly found in children and to very less extent in adults, and they function in generating heat rather than energy. Moving on to metabolism in adipose tissues. Adipose tissue regulates metabolism in health and diseases. They function to store fat majorly in times of excess energy availability, and they break down fat when energy is required. Let us study the metabolism in adipose tissue under two broad headings, that is, what happens to carbohydrate metabolism in adipose tissue and what happens to fat metabolism in adipose tissues. Firstly, about carbohydrate metabolism in adipose tissue. Three events occur in an absorptive state regarding glucose in adipose tissue. Firstly, under the influence of insulin, which is elevated in a post-absorptive state, that is after you have eaten food, glucose enters adipose tissues via the insulin sensitive GLUT4 receptors. Insulin activates GLUT4 receptors. This glucose, which has entered adipose tissue, now is converted to glucose 6-phosphate by the enzyme hexokinase. This conversion of glucose to glucose 6-phosphate in any cell is meant to trap the glucose inside the cell. The second event, because of this glucose entry, is the increased breakdown of glucose which is known as glycolysis. In this glycolysis process, which otherwise serves to provide energy in the body, in adipose tissue the purpose is slightly different. One of the intermediates of glycolysis, glycerol 3-phosphate, is essential in synthesizing triacylglycerol, or which we call as fat. The third event, because of increased supply of glucose, there is an upregulation of the hexose monophosphate shunt pathway, or which is also known as the pentose phosphate pathway, and an increase in this pathway increases the supply of the reducing equivalent NADPH, which is essential for synthesizing fatty acids by the process of de novo synthesis of fatty acids. So, to summarize, in a well-fed state, largely under the influence of insulin, the adipose tissue takes up more and more of glucose, they synthesize fatty acids, and they build triacylglycerol, which gets stored there. Let us move on to fat metabolism in adipose tissue. Fat metabolism in adipose tissue can be studied under two broad conditions: well-fed state and starvation state. In the well-fed state, the triacylglycerol in the food that we eat and which is packaged in chylomicrons in the intestine is delivered to adipose tissues. In a well-fed state, our liver, which also synthesizes triacylglycerol and which is packaged in VLDL, very low density lipoprotein, also supplies this endogenous triacylglycerol to adipose tissues. It may be noted here that chylomicron and VLDL are both lipoproteins. Also, in a well-fed state, since all the raw material is available for this adipose tissue, there is increased synthesis of triacylglycerol, which is called as lipogenesis. In the starvation state, when the body needs energy, the triacylglycerol in adipose tissue is broken down by the process of lipolysis, which provides ultimately energy to the body. So, fat metabolism in well-fed state is an anabolic process. There is building up of fat which is stored in adipose tissue, and during a starvation state, it is a catabolic effect where the fat that is stored is broken down as the body needs energy. It is worthwhile to see the interplay of enzymes in these processes. In a well-fed state, the insulin level increases, and under the influence of this high insulin level, an enzyme lipoprotein lipase gets activated. This enzyme lipoprotein lipase is an interesting extracellular enzyme which is bound on the outside of adipose tissue, and because of its nature of breaking down the lipids, it helps in transporting triacylglycerol from both chylomicrons and VLDL into the adipose cells. Under the influence of insulin again, lipogenesis or synthesis of fat is upregulated. In a starvation state, where hormones like glucagon and epinephrine are high in quantity, the activation of the key regulatory enzyme, hormone sensitive lipase, happens, and this hormone sensitive lipase is essential for the process of breakdown of TAG or lipolysis. To quickly summarize, Insulin levels are high in a well-fed state when we have eaten food. Glucagon, epinephrine, these hormones are high when we are in a starvation state. Under the influence of insulin, the triacylglycerol from chylomicron and VLDL is taken up by the adipose tissue, and this happens by activation of this important enzyme lipoprotein lipase. In a starvation state, we need to break the fat or lipolysis, and a crucial enzyme there is lipoprotein lipase, which gets activated under the influence of glucagon and epinephrine. It is important to slightly mention about diabetes and adipose tissue. Patients with type 2 diabetes mellitus are usually dyslipidemic, that is, the lipid values go haywire, even when the glycemic control is relatively good. The high levels of insulin and insulin resistance, which are associated with type 2 diabetes mellitus, they have two effects on fat metabolism in adipose tissue. Increased lipolysis occurs in diabetes mellitus. The fat is broken down and resulting in high levels of free fatty acid in blood. On the other hand, there is decreased LPL activity, which results in decreased catabolism of chylomicrons and VLDL, which means chylomicrons and VLDL are unable to load the TAG into adipose tissue and their levels are high in the blood. This results in the dyslipidemic picture which we see in diabetes mellitus. A brief note on the endocrine function of adipose tissue is warranted in this topic. Adipose tissue secrete a host of small molecules that act like hormones. They can be called as adipokines. Of these adipokines, we shall see the two important ones on which a lot of work is going on to address issues of obesity and associated disorders. The first is leptin, the other is adiponectin. Leptin has been seen to decrease appetite, it increases the metabolic rate in the body, and a resistance to leptin has been associated with obesity. Adiponectin, a polypeptide, increases fatty acid uptake in muscle and liver. It has also been seen to increase insulin sensitivity, and the levels of adiponectin decreases with decrease in body weight. We have come to the end of the brief topic of adipose tissue metabolism. Let me quickly summarize the highlights of this topic. As we have seen, adipose tissues are located majorly subcutaneously under the skin. They comprise the bulk of the fat. We have 20% of fat of adipose tissue in the around the internal digestive organs. They have various functions starting from insulation, mechanical support to regulation of metabolism. There are broadly two types of adipose tissues, white adipose tissue and brown adipose tissue, with white being the major ones and present in bulk, with brown being very slightly present in adults. Coming to the metabolism that happens in adipose tissue, broadly the two important sets of metabolism related to carbohydrates and fat we have seen. We have seen how in a well-fed state, that is after one has eaten food, the glucose entry increases in adipose tissues, which is facilitated by high levels of insulin, via GLUT4 promoters, GLUT4 transporter. Then we have seen how this will lead to an increase in fatty acid synthesis and ultimately synthesis of fat, which is technically called as triacylglycerol. Regarding fat metabolism in adipose tissue, we have seen how in a well-fed state, the dietary triacylglycerol is transported into adipose tissue, and so does the endogenous triacylglycerol that our liver synthesizes. And both of these facilitated by lipoprotein lipase enzyme, again stimulated by insulin. Whereas in a starvation state, when you need the fat to break down, increased lipolysis occurs under the activation of enzyme hormone sensitive lipase activated by glucagon and epinephrine. We have also quickly seen the role of adipose tissue in diabetes mellitus, how the two processes of increased lipolysis and decreased LPL activity leads to dyslipidemia in diabetes. And finally, briefly, we saw two important molecules secreted by adipose tissue, leptin and adiponectin, which are very importantly related to hunger and ultimately obesity. So that finishes this topic of metabolism in adipose tissue. Thank you.